Hello, and welcome to my AE 1601 Glider Project Final Report. My name is Anand Jha. Let's begin. So, for this project, we were tasked with designing and building a glider that could fly at minimum 20 feet and had to fit inside a 16-inch square. For the name of my glider, I chose to give my glider the name of Bob, and in the middle of your screen you can see Mark III, the third iteration and the final design of my glider. And on the left and right hand side of your screens, you can see the first and second revision of my glider. In this presentation, we'll go through each iteration of the design and show how we improved our glider to create our final product. Starting off, however, we must first go over the design requirements for this project. As stated, the glider must fit inside a 16-inch square. The glider also must be made out of the balsa wood that Professor Zadie gave to us. It must be able to fly a minimum of 20 feet. It must not fall apart after landing. And finally, the glider must be propelled solely with the power of your hand. No rocket thrusters allowed. To measure all these design requirements, the first one, the 16-inch square, we can simply just draw a square and see if the glider fits inside of that. To see if it's made out of balsa wood, just check the components. Is the glider made out of balsa wood? For reaching a distance of 20 feet on launch day, Professor Zadie will have a core set up, and if we pass this threshold of 20 feet, we will know we have hit that goal. Not fall apart after landing, we can simply inspect the glider after it lands and make sure it didn't break. And to make sure that we are only propelling the glider with the power of our hand, we just have to make sure we're not attaching any rocket thrusters to the back of it. Moving on, before we actually start manufacturing our glider, we must first perform some design analysis. The first component of the design that I wanted to make some pros and cons about was the material that I should use for the fuselage of my glider. I had three main options, the first being a plastic straw. These were available to me in the dining hall, so I had access to a lot of them, and I could do a lot of design iterations without having to worry about using up all my materials. Also, these straws are lightweight, but the unfortunate part about them is that they are hard to work with and hard to manufacture on, and that they are pretty weak and can break apart very easily. The second option is the balsa stick that Professor Zadie provided to us, and this stick has high structural integrity, meaning that it would probably not fall apart. The issue with it, of course, is that it is quite heavy. Finally, we have balsa sheet, which Professor Zadie did provide to us, and it is very lightweight. The issue with this, of course, is that it's hard to attach other elements of the glider to it because it is so thin. Another component of the glider that we had to make a pro and con list about was the wing shape. We have three choices here again: an elliptical wing, which does reduce the induced drag, which is a good thing, but it is significantly harder to manufacture and can stall very easily. Second option being tapered wings, which are easier to manufacture compared to elliptical wings, but they can create stall at the tip, which is not good. Finally, we have rectangular wings, which are again easy to manufacture, but they do have a high induced drag. Our third design component that we analyzed was the adhesives that we used to hold our glider together. The first option was actually no adhesives. This would be very lightweight, as we of course have no adhesives, and we would have no sticky stuff on our glider. The issue with this, of course, is that the glider could break because there is no glue holding it together. Our second option is Scotch tape, which looks pretty clean because it is see-through, and it's not super sticky, but I don't have a lot of it, so I would have to be very conservative, and I would be scared to run out of it. Finally, a third option that I had was an Elburns glue stick. This is pretty strong, and I do have access to a lot of it, so I can be as liberal as I want. The issue, of course, is that it's pretty heavy and is sticky, and the purple color would not be nice to see on our glider. With all these design considerations taken in, for the first iteration of my design process, I chose to use a plastic straw for my fuselage with elliptical wings and no adhesives. Also, I added some Play-Doh to the front of my glider because I wanted to make sure my center of gravity was ahead of my center of pressure. I used a plastic straw because since I had so many of them, I wasn't really concerned that if this design failed, I would run out of materials. The performance of this first design was that I found that it was very hard to manufacture and work with a straw just because it's a straw, it's not really meant for gliders, and also because the straw was so weak it would break apart after flying, which would negate my score on launch day. Also, this glider was somewhat unstable, but it was sometimes able to reach 20 feet, but only sometimes. Here in this video, you can see the glider falls apart after landing, which is not good. Moving on to the second iteration of my design, I chose to replace the plastic straw and use a balsa stick instead for my fuselage, and I used tapered wings because I found those were easier to manufacture than elliptical wings. I used an Elmer's glue stick on this glider as my adhesive, and because I felt that this would be the strongest way to make sure my glider doesn't come apart like it did with the plastic straw. This second iteration of my design was easier to manufacture, and it did not break apart and was fairly stable. The issue with it, of course, was that it was not able to reach 20 feet because the balsa stick was just so heavy and because the adhesive that I used was heavy. Moving on, we go on to my third design iteration, which ended up being my competition glider. This was designed using a balsa sheet for all of its components, and it had tapered wings and no adhesives, meaning that it was very lightweight. And again, there is some Play-Doh at the front. This glider, as I said previously, was my competition glider, and some notes about it was that it was easy to manufacture, especially compared to the plastic straw. It was lightweight, did not break apart, and was fairly stable in its flight. And on launch day, it was able to surpass the 20-foot goal, going 46 feet in total, which you can see in this video. As shown, I was able to pass the fourth rung and get close to the fifth one, giving me a total distance of 46 feet. Again, this glider had some Play-Doh at the front to help move its center of gravity, and it had some dihedral to its wings to increase its lateral stability. Some more information about my final design. The glider was 9 inches by 7 inches in total size, which meant that it was very easily allowed to fit inside the 16-inch square, and my center of gravity was located about 1.25 inches away from the nose, the tip of the glider. Finally, calculating the coefficient of lift and the coefficient of drag for this glider. The coefficient of lift, given that my alpha was about 5 degrees or 0.087 radians, was around 0.548. Using that value, I can calculate my coefficient of drag, given that my aspect ratio is about 6.2. And finally, my coefficient of drag was about 0.0154. So revisiting the requirements, we can see that my glider was able to fit inside a 16-inch square. My glider was made out of balsa wood. It did reach the 20-foot minimum distance. It did not fall apart after the landing. And of course, my glider was propelled only with the power of my hand. It did not have any external power. So a summary of this project and some key takeaways that I had. The first being that the glider should be easy to manufacture, especially if you don't have access to high-end machinery, such as CNC machines. Also, you need to make sure that your glider has decent structural integrity while being lightweight, because you want to make sure it doesn't break apart, but it can reach the 20-foot distance. Also, I would recommend for students that they should add some dihedral to increase the lateral stability of their glider, and to make sure that they add some weight to the nose of their glider to push their center of gravity ahead of the center of pressure. Also, doing some research, I found that an aspect ratio for a good glider was usually around 6. Some ways to improve the design of my glider would be to A, more securely attach my wings and horizontal stabilizer. As you can see in that video, my wings and horizontal stabilizer had a lot of play in them, meaning that each launch of my glider, it had varying performance because it wasn't one set component. And also, I would recommend making the glider a bit bigger to increase its overall mass to make it have more inertia and be more resistant to the wind. Also, make sure to have some Play-Doh on you in case the Play-Doh on your glider dries out on launch day, which didn't happen for me. Thank you for listening to my presentation. I hope you enjoyed, and here are all